Alright, so in this video we're going to be predicting the actual questions that will come in the May June Pure 1 exam. If you haven't watched the video where I predict the mark distributions for each topic for Pure 1, make sure to watch that one first because it's basically a precursor to this video. Now, in this video I'm going to explain my thought process for picking the questions that I did and also explain some other question types that I expect to come in the May June exam, but I wasn't quite able to fit them into the guest paper. And if you find the guest paper useful, please leave a like and subscribe to our YouTube channel. Let's dive right in. So looking at number one is a discriminant question and it's carrying 6 marks. If you analyze the last 8 papers, so that's from February-March 2023 up to February-March 2024, 7 of those papers have a discriminant question. So I think there's a pretty high chance of a discriminant question coming up in the May-June exam. So be prepared for that. I wasn't able to add hidden quadratics. They also were a bit popular in 2023, so they might come up still. So make sure you are ready for a hidden quadratic. And then going on to number two is a transformation under the functions topic. Transformations are quite popular and appear in virtually every paper, so you should know how to carry out your transformations. And sometimes these transformations will come with a graph. So you're given a graph and you're told that it's transformed into another graph and you have to carry out the transformation yourself. So be prepared for any type of transformation. Number 3 is a binomial expansion question, and if you have looked at the February-March paper for this year, you can tell that this question is very similar to the February-March question. Binomial expansion appears almost every time, so you should always be ready for binomial expansion. I think this question type that I've put, the one where they tell you that the coefficient of a particular term is this and then they ask you to evaluate a constant, is one of the harder applications of binomial expansion. The other questions is usually just a simple expansion. So if you can get this binomial expansion question right, you should pretty much be able to get every binomial expansion question correct. Now, number 4 is a rates of change question that's under differentiation. I haven't seen too many rates of change questions in the past few papers, but I have a hunch that it could come up in the May June series, and most students tend to struggle with the concept of rates of change, so make sure you're prepared for that one, and that's the main reason I put it in there for you guys to practice in case it comes up. Then moving on to number 5. Number 5 is a trig question, and you can see that part A is a show that this particular equation simplifies into, that's kind of like a hidden quadratic, and then part B is a hence solve the equation question. Now for part A, I was torn between putting a show that question and an identity, because in the last 4 papers they are each split equally. 2 of them have an identity question and 2 of them have a show that question. So just be prepared to prove an identity as well. But the concepts that you apply in both these types of questions are the same, because you're just using your understanding of identities to simplify. And then part B is straightforward, you're just solving the trig equation using the information from part A. Number 6 is a circles question. Part A is find an equation of the circle, and it's worth 5 marks because there's quite a bit that you have to do. Now for this question, I was tempted to actually say give your answer in the expanded form, not in the generic equation of a circle, because if you look at the February-March paper, they asked for the expanded form. So you should know how to move from the generic equation of a circle to its expanded form, and you should also be able to move backwards from the expanded form back to the generic equation of a circle. Now for those of you who want to challenge yourself, don't just stop at find an equation of the circle, but go on to give the equation of the circle in the expanded form, just for your own practice. Part B, that's the tangent to the circle at B. That's a straightforward question and it comes up quite often. Then number 7 is just a simple circular measure question. This one has 2 parts. Part A is find the area of the shaded region. Part B is find the perimeter of the shaded region. They give you a diagram and they give you the information that you need to be able to come up with the area and the perimeter. Now I wasn't able to include a question where you have to evaluate the angle like they did in the February-March series, but you should also be able to evaluate angles. You should understand basic circle theorems and basic circle geometry, because that's usually what you have to apply in these sorts of questions and when you're deducing certain angles, because it usually comes up as a 1-mark question. Find the angle BAD and they give you 1 mark. They're usually looking for you to apply your understanding of circle geometry. That's your sine rule, your cosine rule, and even understanding things like SOHCAHTOA. So make sure that that stuff is on point. Now, number 8, we have our progressions. The sum to infinity question has been quite popular, so I thought to include it. Then for part B, it's just a mixture of a GP and an AP, and I haven't seen them combine progressions in a while, so I thought this would be good practice for you if it does come up. And something that I noticed that I thought was quite strange was that the October-November 2023 papers, none of them had an arithmetic progression. It was all geometric progressions, as well as a binomial expansion question for the series topic, but none of them had an arithmetic progression. So I'm not sure what that's about, but the February-March 2024 paper had an arithmetic progression, so I do assume that it is going to come up in the May-June series. That's why I still included it here. Then number 9, we have a standard functions question. We have part A is a range question, part B you're finding the inverse and you're giving the domain as well, and then part C is a composite function, and this is usually what typically comes up for functions. I noticed that across 2023 you had a transformations question, you had range, you had inverse, and composite functions. I think inverse and transformations appeared in pretty much every 2023 paper, so watch out for those specifically. Then number 10 is a mixture of differentiation. Your part A, you're evaluating k using your dy dx, and then part B you're finding the equation of the curve, so that's a bit of integration. Part C you're locating the stationary point, part D you're determining its nature. So that's pretty standard differentiation and a bit of integration in there. And then finally, the last question is number 11. So number 11, part A is finding the coordinates of A and B. That should be pretty straightforward. And then part B are now using those coordinates to help you find the area of the region between the two curves. And that's a bit of integration. And then you're done with the paper. I know that this paper may be a bit more challenging than the actual exam paper, but I guess that's good since you get to practice with material that's harder than the actual exam. Just to clarify, I didn't have as much time to actually prepare this guest paper as I would have liked. So the data set that I used to help me in coming up with this paper was a little shallow compared to what I would typically use to do something like this. But I think it should be pretty decent and it should be good practice for you guys. That's all for today's video. If you enjoyed the guest paper, please leave a like and subscribe to our YouTube channel, and make sure to tune in tomorrow where we solve the guest paper. Bye bye.